Welcome back to AI for 2021. I hope you're enjoying yourself so far. Our next speaker is Jon Thomason. He is the Chief Technology Officer at Brain Corp. Please join me in welcoming Jon to our virtual stage.
Hello there. My name is Jon Thomason. I'm the Chief Technology Officer at Brain Corporation. And I would like to spend a few minutes with you today talking a little bit about our robots and talking about how we use data. And I think this is a really fascinating topic in robotics today. And to do that, I'd like to start by introducing Brain Corporation because we're not a household name, well, at least yet. Our approach to robots and robotics in general has been a little different than many others. We've started by taking existing manual-driven machines and then build an autonomy kit that turned them into autonomous mobile robots. You may hear AMR bandied about the industry, and that's what it means. Is it a robot that is autonomous, that can drive itself around and do its own thing without human intervention, at least hopefully. This approach has been really successful because we're able to take an existing customer base, existing OEM partners that we work with, and be able to use their sales team, our sales team together to get out and sell into places where they were already purchasing manual machines and just turning those into robots. That opposed to doing a completely purpose-built machine that we were trying to sell ourselves, et cetera. That's a pretty tough sell for people. Whereas if we go at this in this approach where it's a familiar thing but has been turned into a robot, it's been a very successful approach for us. And now we've been able to deploy more than 16,000 robots actually in the field, and almost all of these in very public spaces. Now, it's really great to have a bunch of robots in public spaces, in stores and venues that you visit. Maybe you won't see these all the time because sometimes they work at night, but lots of times they work in the middle of busy stores, in the middle of busy airports and schools and other environments. And it's great to have these in these public spaces because it gives us the opportunity to have insight into data and operations that we can use for, well, quite a few purposes. So let's spend some time talking about that today. Now, we like to think a lot about what a return on investment for a robot needs to be because any machine is expensive and we add on a little bit of extra cost for making it a robot. So how do we make sure there's a return on investment on that? Well, part of it is that just the pure need to have humans doing very boring, repetitive tasks can be eliminated. Now, generally speaking, this doesn't actually eliminate the person. It just lets them go on to do other high value operations, things instead of just the boring task of driving exactly precisely down the aisles, making sure every little bit of the store is clean. The robot can handle that part. And then the employee can be off doing higher value things, types of cleaning that might be difficult for a robot to do if it's cleaning or stocking shelves or other things. But let's take something that's a little more interesting, I think, in some ways, which is let's take the delivery case. Now, you might wonder, what does delivery mean if we're in a store? Well, what a lot of pre-automation workflows look like is a store might have an employee fill a cart in a back room and then push this cart out to their zone for the product and then stock the shelves. Now, using an AMR gives the ability to have a crew stay in the back room who loads carts up, and then a robot take the cart out to where a different employee is stocking their area and takes it out to their zone. And it makes them able to really specialize and know their zones and be really effective at making sure that the store is presentable, and they can be very efficient this way. I vividly recall a stalker at a retail store who thanked us profusely for the delivery robot because she no longer had to push these heavy carts from the back room and could really focus on making her area perfect. We found quite a few hours saved by employees through on the cleaning side and on the delivery side. It's been really fantastic. And as you can see on the slide, we've generated 3.3 million hours of additional productivity just during 2020. So, but on top of that, productivity is only part of it. Sometimes these tasks are dangerous for the employee, like the stalker who was pushing the heavy cart. It was a really heavy cart. It was a couple hundred pounds or more, and it was actually really wearing on this employee. And it was a great relief to her to not have to do that any further. But also, we find that employees are also they damage the stores. They run into things with the floor cleaners, et cetera. And we're able to really eliminate those costs and improve customer experience in lots of ways. But the thing I want to highlight today, and we'll spend all of our time, the rest of our time, is that now the store, the venue, whether it is a retail store where a lot of our robots are, or other environment, they're able to get data that they have not had at their fingertips before. And this is a really big deal. So let's spend some time on that as we go forward here. So all of our robots are connected to the cloud full time. We use cellular wireless technology so that our robots can just be pre-provisioned at the factory. Everything we do is to strive to have really easy deployments. Our value add as Brain Corporation is to make robots that need very little training to deploy. We're able to take employees that have very little or no pre-training. They don't need college degrees, engineering degrees. You don't need laptops to deploy these. Our robots are self-deploying. They're able to go, and we just train a route, and the employee trains a route, and then the robot is able to just repeat that. And it's very simple UI, et cetera. Now, why do I mention this? Because if we use different sorts of connectivity, we might have to have a complex setup environment where we log into various types of store Wi-Fi, et cetera. And they don't work all the same. And there's captive portals and other things that make it very tricky to connect. And so we've just gone with cellular modem technology so that robots just work when they arrive on site. Now, one challenge for us with this is that it does limit the amount of data that we can transfer, given the truly exorbitant costs of bandwidth for business wireless accounts. But then we found ways to selectively bring up the most important data. So as you see here from the slide, we use those connections, those wireless connections, to provision a new robot when we're at the factory. We're able to then activate it at the customer site with very little fuss. We can configure the robots as needed, again, over the air as needed. So if there is, for some reason, some configuration problem, we're able to do this remotely. We don't need to send an engineer to the site. We're able to continue updating the device ongoing, all the way from the very lowest bits, lowest level bits of the operating system, all the way up through our autonomy stack and application stack that makes the robot work. And we frequently update our robots, and it's very little fuss for our end users. And then finally, we are able to stream back lots of data from the robots, things that, and then we'll spend a good chunk of our time talking about what we do with that repository of data. So the first thing, we get this very extensive repository of data. Our robots drive millions of hours in autonomy. And so what do we do with this? Well, lots of things. First of all, from this data, we're able to build test cases, because out of these millions and millions of hours of autonomy, interesting things happen. Robots get stuck in various ways. We see just various types of things happen that are interesting. We're able to make sure that we trigger on those, and anytime that we encounter interesting things, we're able to upload those. And then we can also sample for that as well over time and build up an extensive repository of interesting events. Now, you might wonder what interesting events are, and we could talk about those in some depth, but there's lots of different reasons why robots might get stuck or might not be able to complete their tasks. We log each and every one of those every single time. And then anytime that we are encountering different types of dynamic situations, we can log those as well. And so what this lets us do is it lets us build test cases so that we can develop our software with confidence. There's kind of two ways to think about that. One is that we can test any change we make against regressions in the software. So if we are developing new versions and we want to make sure that we don't break anything, because when you get something that is going to work in many, many different environments, it's very easy actually to make a change that might break something and you won't realize it. So we've boiled down these interesting situations we've seen over millions of hours into thousands of test cases, and we can run every build against these test cases and make sure we don't regress, so we don't go backwards. The other thing we can do, of course, with this data is develop new algorithms, and we're able to take a huge history of events that have happened and find ways to improve our autonomy and bring ourselves into just better compliance with things, or handle situations that we couldn't in the past, and just make smarter autonomy, smarter robots, smoother robots, and use that for our R&D purposes. So for both of those, it's really huge. But there's also a really interesting part for that, and that's for us. That's the selfish part. That's the part that makes Brain Corp better. But also for our customers, we're able to give them insights into how their robots are doing. One thing that you might not, think of immediately is that robots, of course, they do break down. These floor scrubbers are machines. They're scrubbing many, many hours a day, and there are things, both consumables and other supplies, that can be low or need attention. But also there's things where they just fail. Hardware fails over time. We're able to, with our analytics, be able to detect when robot problems are about to happen and get trouble tickets in place for those so that the service can happen even before the customer realized there was a problem. And this is a great thing for our OEM partners. They're able to get out and service these robots efficiently, and it's a really fantastic use of data. Another way we use data, of course, is to give customers insight into cleaning. You know, one of the big things we get from corporate, so let's imagine we're in a big store chain, corporate really wants to know if the stores are getting cleaned, and we can give them proof of cleaning. We can show them which parts are getting cleaned, which parts aren't, how many square feet, how many hours, et cetera, all those sort of things to give them proof of compliance and proof of things. So that's kind of the corporate side. Even at the store level, it's very interesting for a store manager to be able to see how the robot is doing and what the situation is. And in delivery things, same idea. How many hours is it getting used and how efficient are the employees being? It gives management a lot of tools to manage how their results are going. Now, these are sort of I guess I'd kind of call these things obvious, right? The use of data to improve our robot performance, sure, of course. And to use data to be able to let customers see how the robot's being used, of course. But we're going beyond that. And I say obvious, even those sort of simpler cases still take a lot of engineering work. And there's a lot of things that we do that really make customers' lives better and that we keep improving on. But we have a much broader and much grander plans for what we would like to do with this data over time. So let's address those. Our first approach is, hey, I've got a floor cleaner. We've got a floor cleaner in place. Let's show the customer, first of all, let's make sure we can make it better. Let's also show the customer how well it's working and make sure they see their floors are getting cleaned, et cetera. But what else can we do? Well, we can now make this a mobile platform for sensing environments. We can now sense things around us and use this cleaner, which is already in place, cleaning floors, to do other stuff. And we'll talk about those in the next little bit to see what kind of things we can sense. Because I think this is a really interesting thing. You know, once you get a robot somewhere, what kind of interesting stuff does it see? What does it sense? What is it able to see around it? And two of these that we'll talk about especially are virtual tours and the ability to scan shelves. So again, we focused on these two areas first, and there's a lot of value in just giving a manager, whether they're a regional manager, a store manager even, and especially at corporate, this ability to be able to virtually tour their stores on demand. Now, there are lots of platforms out there that will let you kind of build a one-time virtual tour, but they get stale very quickly. And what's actually interesting about a virtual tour is if it's updated frequently, and we're providing the ability for our robots to be able to scan frequently, maybe daily, maybe weekly, depending on the frequency that the store wants. They can set that. But then the nice ability is they can walk through the store and know what they're seeing is actually up to date. You know, kind of a counter example would be, I love going through Google Maps and Street View, et cetera. But the frustrating part about it is those things might be 3 or 4 years old at times. Sometimes it's more often than that, but it's certainly not last week. And the ability to have something that is like that, where it is yesterday or last week, that I can see exactly what the store is doing, super, super powerful. And these tours, and I guess I'm not sure this picture really does it justice, but the idea is that you can walk through and have the ability to navigate through the tour yourself. Walk with the robot exactly where the robot went and be able to see everything it saw. You can scan around, pan around, zoom in, go to a different aisle, skip to a different part of the store, et cetera. And then I think the exciting part to us is the ability to add spatial notes. So you're able to say, hey, this part of the store doesn't look exactly right. There's something that we want to fix here. You can add a note directly in the tour, and then we integrate those notes in the tour directly into their trouble ticketing system so that it makes it actionable for the customer. It's not just that they can scan around, it's that they can actually cause actions to happen by the store staff. And this is what's really exciting about this type of integration with them and that sort of insight. Now, there's lots more future stuff here that we can do with these tours, because the ability to have high resolution images on a frequent basis, inside the store is very, very powerful. And there's lots more things we'll do. But let's also talk about shelf scanning. We have the ability we're putting special cameras on our scrubbers so that they can see very high resolution pictures of the shelves as we go by. And this is really powerful because stores, really thrive on the ability to have a product in front of a customer at the right time. And this ability for a remote manager or a local manager to be able to scan through and see exactly how their products are placed. And of course, to be able to now do analytics on those. Let's see if there's an item is out of stock. Let's see, especially to know where it is. It's actually somewhat surprising to people not in retail that a lot of times stores don't really know where their items are. Because stockers have a fair amount of flexibility in where they place things. And especially when you go into the big box environments, a lot of times, forklifts are running around and they're putting things wherever they can find space. So giving the store the ability to know exactly where a particular SKU, particular product is, and to know if in the absence, particularly of that product, to see if that SKU is not found in the store or not found where it's supposed to be, those sort of things we're automating and giving back to stores and finding lots of great utilization of that. So that's been very exciting. Beyond these things, there's a lot more potential, and we really see a great future for using robots to scan spaces and to really give information and insights back to store managers. Some things we're working on for the future are temperature, lighting. It's interesting, stores are really, store managers and corporate are really interested to have a similar kind of look and feel in their stores. And so one of those big things that we don't think about a lot is how the lighting is. And so making sure lighting intensity is the way that it should be, that there's not burned out bulbs, or that the placement is correct of reflectors and et cetera. We're also looking into RFID solutions to be able to detect what type of products are there at a distance, especially in soft goods. We're also looking a lot into various types of imagery analysis. We're already doing things like planogram compliance and as I mentioned before, the ability to see if things are out of stock and some level of stock counting. But we're going beyond this. We really want to be able to help corporate and regional managers and compliance specialists to be able to see if the stores are in compliance. We're doing things like, we're looking into things like looking for fire extinguishers where they're supposed to be, if exits are blocked, if the width and egress parts of the store are at proper widths. All these sort of things we're looking at, and can make machine learning models that are able to sense these and give these back in actionable form to the stores. So the idea is to make these corporate staff efficient. Right now, they have to do a lot of travel, both local and city to city, just going from store to store to make sure these are correct, and having to pay. Even they're sometimes doing gig economy type workers for this. And some of these we can just replace for the store by using great robotics techniques and great machine learning techniques, and even just letting humans look at it through kind of a remote telepresence setup. So sky's the limit on these things, and we're definitely looking forward to innovating in this area and really making sure that there are remote access to all kinds of data, and making sure the store is well empowered for these things. Now, one thing you might have noticed that I didn't mention here is a lot around people. It is often interesting for stores to be able to see what people are doing, but Brain Corp, we are, because of some of the very tricky privacy and other type of compliance issues around this, where our first efforts are more around stock and other types of compliance, and we're not currently working on tracking people. It's very fraught with complexity and data privacy, and so we're making sure that people feel very comfortable and safe around these robots, knowing that they're not being used to track human beings. So that's our stance right now, and it's something that is going to continue to be a challenge for all types of telepresence, remote or otherwise, for tracking things through cameras. So again, things that we will continue to look into, all the kinds of insights we can give around products, but probably not in the near term around people. Okay, so with that, let me wrap up. Last slide here. It's a big deal for us to work in public spaces. It's not an easy environment to work in. There's lots of dynamism, lots of people moving around. Our robots have to be very careful around people, and they have to be very safe. And we pride ourselves in that. We do a lot of safety certification work with the big certification bodies, and make sure that our robots are safe in these spaces. And then use that safety and comfort people have around these robots to then generate insights for our customers. It's a great future for AI. It's a great future for robotics. And we look forward to being a big part of the ecosystem for retail and ongoing into distribution centers and industrial in the future. So with that, I'll wrap up today. and appreciate your time for this. And we hope that Brain Corporation becomes more of a household name in the future. And we're going to keep selling lots of robots into stores around you. So we hope to see you at least virtually soon.
Wow, Jon, thank you. That was amazing. And I know this virtual audience is going wild with virtual applause. That was awesome. Thank you for sharing with us today.
Thanks very much. Thanks for inviting me. I really appreciate it.
Of course, it's our pleasure. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.